Hello and welcome to our channel INewsYou and find the latest news update. Today, we have a fascinating discovery that sheds light on why we faint and a groundbreaking link between the heart and the brain. This discovery, which comes from recent research published in the journal Nature, reveals that there's much more to fainting than we previously thought. Let's dive into the details. Have you ever wondered why people faint? Traditionally, scientists have explained it as a sudden restriction of blood flow to the brain. But there have always been unanswered questions. What triggers this sudden change in blood flow? What specific parts of the brain are involved? New research in mice provides us with some intriguing answers. The conventional wisdom that fainting is solely due to reduced blood flow gets a significant update in this research. According to Vineet Augustine, an assistant professor of neurobiology at the University of California, San Diego, this is the first step to show there is much more to fainting than just reduced blood flow. While blood flow reduction does play a role, there are other brain circuits at play, making it more complex than what cardiology textbooks suggest. The key revelation in this study is the role of neurons that connect the heart and the brain. These neurons, located below the skull, send signals from the heart to the brain, leading to a drop in heart rate, blood pressure, and breathing rate. This process may trigger the most common type of fainting, known as reflex syncope. This type of fainting can be induced by factors like dehydration, the sight of blood, or long periods of standing. The research into the link between the heart and brain in fainting has provided fresh insights into a phenomenon that has puzzled scientists for decades. By shining a light on the role of specific neurons and the vagus nerve, this study opens doors to new possibilities in understanding and managing fainting episodes. One of the central characters in this medical drama is the vagus nerve. This nerve, which is part of the parasympathetic nervous system, plays a vital role in regulating our body's rest and relaxation responses. The research suggests that when people faint, their parasympathetic response becomes exaggerated, causing a dramatic slowdown in their heart rate, blood pressure, and breathing. This discovery highlights the significance of the vagus nerve in the fainting process. Dr. Zachary Goldberger, a cardiologist at the University of Wisconsin-Madison School of Medicine and Public Health, believes that this research brings hope. He says, "Now that these scientists have helped us to understand that there's a possible mechanism for it, you could potentially imagine that there'll be therapies on the horizon." It's important to note that the findings do not apply to fainting caused by underlying heart problems such as extremely slow or fast heart rhythms. These instances are rarer and more dangerous. To understand the role of the vagus nerve, the researchers conducted experiments on mice. The vagus nerve is a vital part of the parasympathetic nervous system, responsible for helping the body rest and relax. The study's aim was to determine if the vagus nerve played a role in fainting. The researchers examined the internal organs of mice under a microscope and identified a specific stretch of neurons within the vagus nerve. The researchers took a significant step by testing whether stimulating these specific neurons in mice could induce fainting. Jonathan Lovelace, a co-author of the study, explains the procedure. We have this little fiber which we put into their brains, and we can shine just a little tiny bit of blue light to activate these neurons. The results were intriguing. The mice displayed classic signs of fainting, including a drop in blood pressure, breathing rate, and heart rate. Their pupils dilated, and their eyes rolled back into their heads. The use of mice in the research proved to be a pivotal step in our journey of understanding. These tiny creatures allowed scientists to conduct experiments that illuminated the role of specific neurons in the fainting process. By activating these neurons, researchers could induce fainting in mice, providing further evidence of the connection between the heart, brain, and fainting. While these findings are promising, it's essential to acknowledge that there's still much to learn. The researchers have yet to determine what triggers this nerve pathway in real-life scenarios, and whether the results can be directly translated to humans. Fainting in humans can have various causes and nuances. Before this research, scientists primarily attributed fainting to insufficient blood flow to and from the heart. According to Dr. Shamai Grossman, an associate professor of emergency medicine at Harvard Medical School, you're not going to get blood to the rest of your body, including your brain, and you'll pass out. Most of the time, fainting isn't a major concern unless it occurs in situations like driving or causing injuries due to falls. Approximately 40% of people experience a fainting spell in their lifetime, often triggered by seemingly minor factors. Fainting can be triggered by various factors, such as standing for extended periods, thirst, or pressure on the chest, like in pregnant women or beginners playing musical instruments. Surprisingly, emotional responses, whether to bad news or something funny, can also cause fainting because the body overactivates the parasympathetic nervous system to induce calmness. While there's currently no foolproof way to prevent spontaneous fainting spells, the discovery of the specific neurons involved in the vagus nerve pathway could pave the way for new approaches. For instance, doctors might explore gene therapy or targeted nerve stimulation in the future, targeting the genes related to the vagus nerve. In conclusion, the age-old mystery of fainting is slowly unraveling, thanks to groundbreaking research in mice. The connection between the heart and the brain is more intricate than previously believed, offering potential avenues for future therapies. While there's still much to learn and apply to humans, this discovery is a significant step towards understanding and addressing fainting episodes. Stay tuned for more updates on this exciting development in medical science. Thank you for joining us today.